These are your notes for Unit 5, Day 2 of Algebra. If you would like to see the warm-up, our review question, or any homework questions we covered in class today, just look at the finished notes. So today, we are going to solve systems of linear equations again, but instead of solving by graphing like we did last class, we're going to solve using a method called substitution. So we've actually been using substitution all year. So when we evaluated expressions in our first unit, so evaluate when x is equal to -2, you were substituting. So we're going to take the -2 and we're going to substitute it in for x in the expression. And remember when we substituted, I recommended that every time you substitute, you should put what you're substituting in parentheses. So this is going to be 3 times the quantity x minus 5. So it'll be 3 times -2 minus 5. And so we are going to do the inside of the parentheses first for order of operations. -2 minus 5 is -7. So this becomes 3 times -7, which is -21. So when we substitute in -2 into that expression, we get -21. In the next expression, we're going to evaluate when x is equal to -1 and y is equal to 3. So we're going to take -1 and substitute it in for the x. And we're going to take 3 and substitute it in for the y. And so we get 2 times -1 minus 3 times 3 plus 5. And 2 times -1 is -2. -3 times 3 is -9, and then plus 5. -2 minus 9 is -11, and -11 plus 5 is -6. So when we substitute in -1 for x and 3 for y, we get -6. All right. So solving a system of equations using substitution, you first need to solve one of the equations. So you want to solve one equation for either x equals or y equals. So you need either the x to be by itself or the y to be by itself in one of the equations to use substitution. So let's look at our first example. Y plus 5x is equal to 8. And y is equal to 3. Now, if you notice in that second equation, y is isolated. Y is by itself, so we're good to go. We don't have to do anything first. We can take 3, and we can substitute that 3 in for y in the first equation. So my first equation now becomes 3 plus 5x is equal to 8. And now we're going to solve that equation for x. So we're going to subtract the 3 from both sides, and we get 5x equals 5. And then we'll divide both sides by 5. And we get x equals 1. So in that system, to solve it, we get x is equal to 1 and y is equal to 3. Now, last class, we solved by graphing. So if I were to graph those two lines, they should intersect at the point 1, 3, just like we found with substitution. So if I took y plus 5x equals 8 and I wanted to graph it, I would subtract 5x from both sides, and I would get y equals -5x plus 8. So I would start this at positive 8 on the y-axis, and then I'd go down 5, 1, 2, 3, 4, 5, and over 1. And then we need (1, 2, 3, 4, 5) over 1. And then we need the equation y equals 3, so that is right here. 1, 2, 3, 4, 5, 6, 7. Oh, we need to go one more up. That's what happened. So here's 8. And then we want to go down 5 over 1. So there we go. So my first line is y equals -5x plus 8. And then the second line is y equals 3, which is the horizontal line. And notice, where do they intersect? They intersect when x is 1 and y is 3. So that worked. In our second equation, we have x is equal to -3. And 4x minus 2y equals 15. So, again, when we want to solve using substitution, either the x needs to be by itself in one equation or the y needs to be by itself in one equation. And we have x is equal to -3. So we can take that -3 in the first equation, and we could substitute it in for the x in the second equation. So this is going to be 4 times -3 minus 2 times y equals 15. So -12, 4 times -3 is -12. -12 minus 2y equals 15. Then we're going to solve for y. So we'll add 12 to both sides, and we get -2y equals 27. Then divide both sides by -2, and y is going to equal 27 over negative 2. So that's going to be the y coordinate, and then my x coordinate is negative 3. So if I were to graph those two lines, they would intersect when the x coordinate is negative 3 and the y coordinate is 27 over negative 2. And you can always check your work by plugging back in. So again, to solve a system using substitution, you need to solve for either x or y in one equation. And then you get to substitute that expression or number into the other equation. All right, let's solve the following using substitution. We have y is equal to 3x minus 1 and y is equal to 2x plus 4. So again, in order to solve using substitution, one of the equations need to say y equals or x equals. So the y or the x needs to be by itself. Well, in the first example, they're both by themselves. So we know that y is equal to 3x minus 1. So now I'm going to substitute that entire expression, 3x minus 1, because that's what y is equal to. I'm going to substitute it in for the y in the second equation. So now I have the expression 3x minus 1, I'm going to substitute it in for the y, is equal to 2x plus 4. Well, I'm not multiplying that parentheses by anything, so I just have 3x minus 1 equals 2x plus 4. And now I'm going to solve that equation. I have x's on both sides, so I need to move so my x's are on the same side. So I'm going to subtract 2x from both sides so that the 2x's on the right side will go away. And I have 1x minus 1 equals 4. And then I'm going to add 1 to both sides, and I get x is equal to 5. Well, now I know the x coordinate that will be where these two lines would intersect if I graphed them. They would intersect when x is equal to 5. But now I need to figure out what the y is. They didn't tell me at the start what the y was as a number. They just told me what y was as an expression. We know that y is equal to 3x minus 1, or you could do y equals 2x plus 4. And now we're going to have to substitute again. We're going to take, now that we know that x is 5, I'm going to take that 5 and substitute it in for x to figure out what the y coordinate would be. So y is going to equal 3 times 5 minus 1. So y is going to equal 15 minus 1. So my y coordinate is going to be 14. So if I were to graph those two lines, they should intersect when x is 5 and y is 14. And again, you can always check your work by plugging in your answer into both of the original equations. So does 14 equals 3 times 5 minus 1? So I'm substituting in 14 for y and 5 for x. Is that a true statement? It is. And then does 14 equal 2 times 5 plus 4? It does. So the point 514 works in both of these equations, so we solved it correctly. Let's look at the next one. Negative 2x plus y is equal to negative 5, and 2y minus 3x is equal to 4. So remember, for step 1, we either need an equation to say x equals or y equals. So one of those equations needs to have either the x isolated or the y isolated. Now notice, neither of those equations do. So now we have to pick one variable in one of the equations to solve for. So looking through, if I wanted to solve for negative 2x, I would have to subtract the y and divide by negative 2. I could do that, but that doesn't seem like a whole lot of fun. If I wanted to solve for the y in the first equation, I would just have to add 2x to both sides. That's not terrible. I could do that. In the second equation, if I wanted to solve for the y, I would have to add the 3x to the other side and then divide by 2. I could do that, but it's too many steps for right now. If I wanted to solve for the negative 3x, or the x in the second equation, I would have to subtract the 2y and then divide by negative 3. So the easiest variable to solve for, the one that I would have to use the least amount of steps to solve for, is the y in the first equation, because the only thing I need to do to solve for y is to add the 2x over. So I'm going to do that. So I have negative 2x plus y equals negative 5. That's my first equation. I'm going to solve that equation for y. So I'm going to add 2x to both sides. So I get y equals negative 5 plus 2x, or 2x minus 5. You could write it either way. So now, since I know that y is the same thing, or is equal to 2x minus 5, now I can take that 2x minus 5 and I can substitute it into the other equation. Well, my other equation was 2y minus 3x equals 4. So I'm going to take the 2y minus 3x equals 4, and I'm going to substitute the 2x minus 5 in for y. And remember, when we substitute, we like to put it in parentheses. So this is going to be 2 times y. So it'll be 2 times 2x minus 5. That's what y is going to become. then minus 3x equals 4. And now I'm going to solve this equation. So I'm going to distribute the 2, and I get 4x minus 10 minus 3x equals 4. I can combine like terms because the 4x and the minus 3x are on the same side, and that becomes 1x minus 10 equals 4. And then I'll add 10 to both sides, and I get that x is equal to 14. So again, if I were to graph those two lines, the x-coordinate where they would intersect would be 14. I'm not done though, because in order to figure out where they intersect, you need both an x-coordinate and a y-coordinate. So now I need to find the y-coordinate. I'm going to add a page so I have more room. So if I want to find the y-coordinate that goes with it, now I've got to substitute this x is equal to 14. I have to substitute it in to one of the equations. I can substitute it into the top, I can substitute it into the second equation, or I can substitute it into the equation that I simplified, y equals 2x minus 5, and that's what I'm going to do. So I know that y is equal to 2x minus 5 because I already simplified that equation. And now I'm going to take the 14 and plug that in. So y is going to equal 2 times 14 minus 5. So y is going to equal 28 minus 5. So y is going to equal 23. So if I were to graph those two equations, they should intersect when the x-coordinate is 14 and the y-coordinate is 23. And if we were to substitute this back in to both of those equations, it should work. So if I plug in 14 for x, then I get negative 2 times 14 is negative 28. And negative 28 plus positive 23 is going to equal negative 5, so that works. If I plug them into the second equation, 2 times y, that would be 2 times 23 is 46, minus 3 times 14, and we would get 4 out of that. So the point 423 works in both equations. All right, let's look at another couple examples using substitution. So we have 4x plus y equals 11. And 2x plus 5y equals 1. Again, we need to solve one of these equations so it says x equals, it says x equals or it says y equals. So either the x needs to be by itself or the y. In the first equation, if I try to solve for x, I would have to subtract the y over and then divide by 4. That's doable. If I wanted to solve for y in the first equation, I would just have to subtract the 4x over. That seems easy enough to do, so that's what I'm going to do. So if I want to solve the first equation so that y is by itself, I'm just going to subtract the 4x from both sides. And I get y is equal to negative 4x plus 11. So now that I know what y is the same thing as negative 4x plus 11, I'm going to take that and I'm going to substitute it in for y in the other equation. So I'm going to take the other equation, 2x plus 5y equals 1, and I'm going to substitute in negative 4x plus 11 into the y. And again, I'm going to put it in parentheses, so I have 2x plus 5 times negative 4x plus 11 is equal to 1. Distribute that 5, and I get 2x minus 20x plus 55 equals 1, equals 1. Combine like terms, 2x minus 20x are on the same side, so that would be negative 18x plus 55 is equal to 1. And then I'm going to subtract the 55 from both sides. And I get negative 18x equals 1 minus 55 is negative 54. And then I'll divide both sides by negative 18. And negative 54 divided by negative 18. X is going to equal, that would be 27 over 9. So x is going to equal 3. So the x-coordinate, where those two lines would intersect, would be 3. But now I've also got to find the y-coordinate. I'm going to use the equation y equals negative 4x plus 11, which is what I solved for at the start. And I'm going to plug in 3 for x. And I get y equals negative 4 times 3 plus 11. So y is going to equal negative 12 plus 11. So y is going to be negative 1. So these two lines should intersect when x is 3 and y is negative 1. So if I test that out, x is 3 and y is negative 1, do these make true statements? 4 times 3 plus negative 1 does equal 11, that works. And 2 times 3 plus 5 times negative 1, that would be 6 minus 5, that equals 1. So the point 3, negative 1 is correct. Let's look at our next one. We have y is equal to 1/2 x minus 4 and 2x plus y is equal to 16. Well, notice one of our equations, y is already by itself. So I can take that 1/2 x minus 4 and substitute it in for the y in the second equation. So I have 2x plus, substitute 1/2 x minus 4 in for y, equals 16. Again, I'm just multiplying by 1, so the parentheses aren't needed. So 2x plus 1/2 x minus 4 equals 16. 2x plus 1/2 x is 2.5x. So 2.5x minus 4 equals 16. Then I'm going to add 4 to both sides, and 2.5x is equal to 20. Then divide both sides by 2.5 and 2.5. And x is going to equal 8, I believe. Yeah, 2.5 times 8 is 20. And so my x coordinate is going to be 8. Now I've got to find my y coordinate. I know that y is equal to 1/2 x minus 4. That was given in the problem. So if I plug in 8, y is going to equal 1/2 8 minus 4. Half of 8 is 4, and 4 minus 4 is 0. So these two lines should intersect at the point 8, 0, which is also the x-intercept. So if I try it, if I plug in 8, I should get 0. So 0 equals 1/2 times 8 minus 4. That's true. And then 2 times 8 plus 0 equals 16. That's also true. So I solved it correctly. We got the point where those two lines would intersect would be the point 8, 0. So that would be the solution to the system. All right, let's go ahead and try some more. 4x minus 3y equals 12 and negative 8x plus 6y equals 30. I need to solve one of those equations for either x or y. If I try to solve the first equation for x, I would have to add the 3y over and then divide by 4. If I wanted to solve it for y, I would have to subtract the 4x over and then divide by negative 3. On the second one, I would have to, if I wanted to solve for 8x, I would have to subtract the 6y over and then divide by negative 8. Or to solve for the y in the second equation, I would have to add the 8x and then divide by 6. Well, I'm just going to pick the smallest number. I'm going to solve for the y in the first equation. So 4x minus 3y equals 12. To solve for y, I'm going to subtract 4x from both sides. And I get negative 3y equals negative 4x plus 12. And then I'm going to divide everybody by negative 3. And so I get y equals 4/3 x minus 4. So now that the y is by itself, I can take that y and I can substitute it in for the y in the second equation. So my second equation is negative 8x plus 6y equals negative 30. So I'm going to substitute my newfound value in for y. So I have negative 8x plus 6 times 4/3 x minus 4 equals negative 30. So I'm going to distribute. 6 times 4/3 would be 24 over 3. So that would be 8x. So I have negative 8x plus 8x minus 24 equals negative 30. Negative 8x plus 8x, well, when I combine those, I get 0. So those cancel each other out. So I'm left with the expression negative 24 equals negative 30. That's not a true statement. And if you remember from when we solved the equations earlier, when you're left with not a true statement, this means that there's no solutions. Do you remember from last class what types of lines would have no solutions? What lines would never intersect? Parallel lines. So that means that at the start of this problem, these two lines are going to be parallel. They're never going to intersect, so they would have no solutions. So if I went to graph them, they would have the same slope. But again, I went through, my x's canceled out, and I was left with a statement that wasn't true. Negative 24 is not equal to negative 30, so there's no solutions. Let's look at the next one. We have y is equal to 2x minus 3. Well, since y is by itself, I can take the 2x minus 3 and just substitute it in for the y in the second equation. So negative 4x plus 2, and then the y is going to become 2x minus 3 equals negative 6. I'll distribute the 2, so I have negative 4x plus 4x minus 6 equals negative 6. And now notice we have a negative 4x and a positive 4x on the same side, so those will cancel. So now I'm left with the equation negative 6 is negative 6. That's a true statement. So remember, when you have a true statement, that means when we solved normal equations, you would have all real numbers. This one, you're going to have infinite solutions. And do you remember what happened when you graphed them to make you have infinite solutions? That was when you graphed them and it was the same exact line twice. So if you were to graph these lines, they would both be 2x minus 3. So both of them would be down 3 and then up 2 over 1. Both lines would be directly on top of each other. So they would both be the line 2x minus 3. So they would have infinite solutions. Every point on that line would be a solution. All right, let's look at this doozy. Negative 5y plus 6y equals 3x plus 2x minus 5 minus 3x plus 5. And 4 times the quantity x plus y minus x plus y equals negative 12. Well, the first thing we're going to need to do is we're going to have to simplify both of these. So let's start with the first one. Negative 5y plus 6y equals 3x plus 2 times x minus 5 minus 3x plus 5. So let's combine like terms. Negative 5y and 6y on that side will just be y. So I have y equals, now I'm going to distribute over here, 3x plus 2x minus 10 minus 3x plus 5. If I combine like terms on the right side, 3x plus 2x is 5x, and 5x minus 3x is 2x. So I have 2x, and then I'll combine my numbers. Negative 10 plus 5 is negative 5. So I have y is equal to 2x minus 5. Okay, so now I've simplified that top equation. So now I'm going to simplify the bottom equation. The bottom equation was 4 times x plus y minus x plus y equals negative 12. Let's distribute. 4x plus 4y minus 1x plus 1y equals negative 12. Combine like terms. 4x minus x is 3x. And then we have 4y plus y, that would be 5y. So 3x plus 5y equals negative 12. So now these two equations are my system. Now notice one of the equations is already solved for y. Y is equal to 2x minus 5. So now I can take that 2x minus 5 and substitute it in for the y in the second equation. So now this is going to become 3x plus 5 times 2x minus 5 is equal to negative 12. Distribute the 5. So 3x plus 10x minus 25 equals negative 12. Combine the like terms. We have 13x because 3x plus 10x is 13x. They're on the same side. Minus 25 equals negative 12. Add the 25 over. And we get 13x equals 13. Divide by 13 on both sides. And x is going to equal to 1. So my x coordinate for my solution is 1. Now we've got to find our y coordinate. So we're going to take the 1 and substitute it in for y in our equation. So y is going to equal 2 times 1 minus 5. And 2 times 1 minus 5 is negative 3. So those two lines, once you simplify them down and graph them, would intersect when x is 1 and y is negative 3, or at the point 1, negative.